Hello, everybody, and welcome to today's Via Satellite Technology webcast titled Rethinking Ground Segment as a Service, presented by Viasat. My name is Jeffrey Hill, Executive Editor of Via Satellite and Chair of the Satellite Show. Thank you all so much for joining us today. Today, I'll also be your host for a discussion about Ground Segment as a Service, the new real-time Earth solutions business that Viasat established in this arena a year ago. Viasat accomplished this by creating a network of globally dispersed ground stations for Earth observation or remote sensing communities to address diverse mission requirements. This ground segment as a service solution includes automated ground infrastructure with an ability to be agile across satellite inclinations and orbits and to enable optimized high throughput for customers. So to discuss how and why Viasat real-time Earth business was built, as well as the advantages it provides to customers, we are joined here by Aaron Hawkins, Director of Viasat Real-Time Earth. Aaron, thank you so much for being with us today.
Thank you.
Aaron serves as its business and strategic account manager. He is charged with enabling the network's global expansion and developing innovative solutions to enhance the RTE customer experience. We were also supposed to have John Williams, who is the Vice President of Viasat Real-Time Earth, but unfortunately he was ill today and could not make it. So when Aaron is finished with his presentation and we go to the Q&A portion of today's webcast, we'll be joined by Eric Eliason, the Director of Business Development for Viasat Real-Time Earth, to answer your questions. So Aaron will take over and give a presentation at first, and then, as I said, we will answer your questions. You can submit those questions using the Q&A tab at the right-hand side of your screen. We will get to as many of those questions as we can in the time that we do have. And if we don't answer your questions, Viasat will reach out to you offline to answer those questions. And obviously, we'll also have John, provide input if necessary. So if you were looking to come on and talk to John or hear from John, he can maybe reach out to you offline with those questions. So with that said, we have a lot to talk about. Aaron has an opening presentation. I will turn it over to him. So Aaron, the floor is yours.
Okay, thank you very much, Jeff. I appreciate it, and thanks to Viasat for having us on today. I look forward to this opportunity to talk to everybody a little bit more about Viasat Real-Time Earth, our new ground segment as a service business area. Tell you who we are and what we're doing, and then having a fun little Q&A on where we see the industry going. Encourage a lot of involvement, and I know we're going to get a lot of good questions out there. They say Murphy's Law is in effect when you get the information that you're going to be giving the presentation the day of. I wish John well. Hope he gets to a speedy recovery, and I trust that you're in good hands with Eric Eliason and myself today. So Viasat Real-Time Earth. As mentioned, I'm the director for Real-Time Earth, and in that role, as Jeff said, I'm responsible for building relationships and building out this global network. As you'll see later in the presentation, we have partners all over the world that we've formed very strong bonds with. We've got great relationships with that have helped us grow from all different walks of industry and government and nonprofit. I'm also charged with business development in the commercial sector, where we've taken that same philosophy, trying to find win-win relationships throughout commercial. And my colleague Eric Eliason, who will be joining us for the Q&A, is working closely with government. We are a commercial service, but we are a provider for both government and commercial, government and industry. Now, moving on, let's start with the big picture. Some of you might not know who Viasat is, so we are a global communications company, believing that everyone and everything can be connected. And it's with that mantra that we started many moons ago with the Wild Blue internet service, expanding into Viasat 1 satellite, which became the highest capacity satellite ever on orbit. Viasat 2, doubling that, again, just increasing connectivity. starting out in the US, then expanding into the Caribbean, Mexico, and the air bridge between the Atlantic and the United States. And with our Viasat 3 constellation, we will be global, providing high-speed internet throughout the entire world. A quick snapshot of Viasat. Founded in 1986 and just have had tremendous growth ever since that time. This slide is a little bit outdated because we're just moving so fast as a company. We have more than 60 offices around the globe. You've perhaps seen press releases recently where we've opened up offices in the UAE and elsewhere. I'm personally responsible for some of the growth we've seen in Africa and offices in Ghana and South Africa. Currently have 4 satellites on orbit and should have 7 satellites on orbit within 12 to 18 months when we launch and commission the Viasat 3 satellites. Well over 5,800 team members now, 2.3 billion in revenue with 2.7 billion in new contracts, growing quite rapidly. Now I'm going to zero in a little bit on Viasat Atlanta. In around 2000, Viasat acquired the antenna systems arm of a company called Scientific Atlanta, who those who have been in the industry for a while should know well and have heard of. Scientific Atlanta, now Viasat Antenna Systems, brought with it a heritage going back to the Apollo lunar missions of providing tracking antennas. So well over 50 years of just tremendous experience, expertise, and knowledge on all things antenna theory and antenna systems, and had tremendous success with those as a product. And that's from anything from the airborne terminals we provide for our Viasat in-flight connectivity service, the Kuka terminals, which are Ku K-band capable phased array antennas, to what you see in the top of the screen there. That's not a stock image. That's actually taken from Atlanta in our new test and factory acceptance area for large aperture antennas. Those are 18 and 24 meter antennas that were just recently stacked and tested for one of our customers. We go anywhere from 2.4 meter all the way up to 24 meter full motion SATCOM, limited motion, and all that out of the Atlanta office, where we do the integration, perform factory acceptance testing, can do near field, far field testing, have an anechoic chamber, over 500 employees with 50% of whom are engineers, bringing that technical expertise that I was just talking about. Now honing in even more, let's talk about Viasat Real-Time Earth, the reason why I'm here today. So Viasat Real-Time Earth was a concept that we came up with 5 or 6 years ago, really in the idea phases. It was a time of tremendous growth in the new space industry, a paradigm shift in the industry where, and satellites used to cost 100 million. Then they went down to 100,000 for certain types of satellites, right, to fly. So a lot of the new space entrants needed another solution. There was a lot of people that needed a US solution. So we saw a niche there. We're not trying to be everything to everybody, but we did find an area there where we felt like we could help the satellite industry, satellite operators in particular, grow. That's what started Viasat Real-Time Earth ground service, and it's depicted in the slide with RTE ground, where satellite operators get direct access to an RTE antenna for tracking, telemetry, and control or command, and payload downlink. And we're expanding that on to RTE space, which we're very excited about. It's going to be a one-of-a-kind combination service where you would be able to provide RTE ground, RTE space, or a combination of both of them for satellite operators. We'll get more into that in a few minutes. So RTE ground RT Ground was designed for both the legacy satellite operators out there, but with a mindset for new space, where there have been tremendous innovations, primarily in automation, but also in virtualization, where we're able to dramatically bring down the cost of ground, where you no longer, we don't view it as a series of antennas. We view this as a network that is connecting satellite operators to their satellites. And the antennas only serve as part of that, a node in that virtual network that we provide to our customers. And as part of that, you need a fully automated lights out operation as almost table stakes in this. So when our customer goes over an RTE site, that site, for all intents and purposes, virtually becomes their antenna. It's loaded with their configurations, their waveforms, their modcods. We have software-defined radios for both TT&C and high speed, high rate downlink payload data on site, where we can, on a moment's notice, deploy updates and changes and new configurations for our customers who are completely firewalled off from any other customers. And once their pass is over, they're firewalled off again, and then a new customer can come in and take over the next pass. And we started RT with 5.4 meter antennas that were S and X band. I'll talk a little bit about that in a minute, but we saw an opportunity to move to the future and have since standardized on 7.3 meter SX and KA band antennas, and that's all over the EESS allocation ITU. So the KA band is the 25.5 gigahertz to 27 gigahertz. With this virtual network of antennas, and by removing the man in the middle, so to speak, we're able to make onboarding easy, make updates easy, inject technology easy, and have competitive pricing across the board. It also reduces any excess costs and human error. I've heard our co-founder, Mark Dankberg, once say, anything that can be automated should be automated. And we took that to heart in RTE, as fully an automated service as we can get, and pushing it ever further every day. I remember a customer once being surprised. He asked me, I need to be able to confirm a pass within 3 days. And I said, well, the pass is confirmed the second you schedule it. We've got to, again, it's lights out, no man in the middle. If there's an availability and you schedule a pass, you've got the pass. We also provide that compute at the edge. That's through the VHR 3200 FPGA enabled high rate modems. These are optimized for KA band and X band high speed connections, offering some of the highest commercially available downlink rates that you can get. So where are we a little bit different? We're a US company that's fielding its own technology, which allows us some ways to inject new technology and to keep the availability up at high rates. And we're providing the highest commercially available cybersecurity protocols. This is the same team that provides security for our global internet service, or starting in the US, the Viasat internet service, and then our in-flight connectivity service is also providing cybersecurity for RTE. Talk a little bit about where we are and where we're going. We're currently operational with the 5.4 meter antennas that I mentioned earlier. The S and X band antennas, those are in the UK, here right outside of Atlanta, Georgia, and in Cordoba with our partners at the CONAI Space Agency in Argentina. And after that, it's when we standardized and moved towards the 7.3 meter tri-bands, which all RTE antennas are going forward, with some exceptions, which we can talk about in the Q&A. But we have two 7.3 meter SXK band antennas in Australia. We're operational in Ghana with a sister antenna. Just went operational in Ojibin, Sweden. And we are well underway in South Africa to be operational in the summer, and as well as Hokkaido, and then a few months later in southern Japan. And the plans don't stop there. We are full believers in space, the space economy, and being able to provide global coverage for our customers. So as you can see, the expansion is going to continue. We're looking at least 4 antennas a year, um, depending on usage and need of our customers and requirements. I mentioned the win-win philosophy earlier. That's something that we are firm believers in, whether it's with our customers, with our cloud-based partners, different platforms we use, and our site partners. If both sides aren't winning, then it's not going to be a long-term relationship, and this is a long-term game. So we've established close relationships with many other GSaaS providers as well, with cloud providers like AWS and Azure. Uh, we are cloud agnostic ourselves. We can work with anybody wherever our customers need their data to go. We can arrange for it to go. We've got strong partnerships with Cubos and Emergent. Emergent provides our TTNC radio, satellite defined sat track, or sorry, not satellite, software defined sat track radio. And in our sites, you'll see that they're quite diverse. They're everything from private companies to space agencies to nonprofit organizations. In each of them, we've been able to establish relationships where, as I mentioned before, it's a win-win relationship where we bring business to them, they bring business to us. We increase, for example, in Ghana, we're helping to stand up a nascent space industry in Ghana and investing in the country. And in Australia, we've worked with Indigenous Business Australia and the Center for Appropriate Technologies to have a hosting agreement fully funded with an Aboriginally owned company in CFATSI, the satellite, or Center for Appropriate Technology Satellite Enterprises. So wrapping up RTE Ground, and this is a beautiful picture of our antenna with Arctic Space Technologies in Ojaman, Sweden, that's operational now. We offer a complete network. We like to keep it simple. We don't want additional charges for our customers, so we try to provide everything. That includes up to a gigabit of service at every site. It includes access to every site. It includes the technology infusion that we provide. It includes Viasat VHR 3200 high rate software defined radios. And I encourage you to look those up if you haven't already, and take a look at the technology that we're putting out there. And this Emergent Sat Track radios as well, which are all software defined, and we're able to update on the fly and deploy to all of our stations. And we also provide that, as I mentioned earlier, that heritage going back to the Apollo days, where we have amazing people working in Viasat Atlanta that have over 30, 40 years of experience working on antennas. And where that's important is when our customers come to us with a problem, we can come back to them with a solution. We've been able to provide really interesting, unique solutions on a case-by-case basis that I can't get into for specific customers, based on that strong knowledge of not only being the ground station service provider, but being the manufacturer of the antennas. And one thing that we're really excited about, and we're just now starting to announce and broadcast, is our upcoming RTE Space Relay service. So this is tied to the Viasat 3 constellation of geosynchronous satellites. If you're not aware, the first one should be launching in late summer of this year, and will cover the Americas, North and South, and should be followed on a 6-month cadence, with the next Viasat 3 satellite covering the Europe, Middle East, Africa region, and then the third covering the Asia Pacific region. With RTE Space Relay, we have already mastered the ability to track airplanes and become really a world-class leader in in-flight connectivity. And we've taken that same technology, the same math, and extended that out to space, where we'll also be able to provide persistent coverage to your satellites in LEO from the geo belt. That's going to be a higher speed connection than you might be used to. So it's capable of both payload and TT&C. It would go over the K-band network, so there'd be no need for additional licenses everywhere, as long as you can go over the Viasat K-band network, which we provide all the regulatory licensing for, and downlinking and uplinking. Then this is just one more tool that makes it easier for satellite operators. It's a proven technology. We're talking RF here, so this isn't new. These are terminals that have been around, or at least the capability has been around for a very long time, and we at Viasat have mastered it. And then you've got this unique ability to integrate both space and ground services, which is, I think, super cool. Everybody we've talked to is very excited about it. Now you've got the opportunity, let's say you're flying a high rate K-band mission where you downlink over our Sweden station and maybe our Ghana station, but you pass over something else where you really need to get that information directly to your end user immediately. You can do that. You can relay that back over the Viasat 3 satellite and get it to the ground almost as it's happening. Now the long leg is not waiting for your next pass. It's however long it takes to process that data. It's a really exciting service that we're rolling out, and plan for it to be operational by the end of 2023, fully operational. Those are all the slides that I have, Jeff. I'm excited about getting into the Q&A. Hopefully I provided enough teaser information out there to get people interested and target some of these questions that we might have.
Thanks so much, Aaron, and for dropping a space relay service right at the end there. That is a tease. And we do have a ton of questions, and we'll get to those. But to help us answer these questions, we're going to bring on Eric Eliason, who's Director of Business Development for Viasat. Eric, there you are. How are you, Eric?
Doing well, thanks. Greetings from Colorado Springs.
Yeah, we just had a space symposium, a very successful event over there in Colorado Springs. So Eric is, as I said, John couldn't make it to this webcast, so Eric is going to step in here and answer questions on the business development end. We have a ton of questions in already, but please ask your questions using that Q&A tab at the right-hand side, because if we don't get to it, Eric and Aaron and John will reach out to you offline to answer your question directly. So please ask while you're here. Also, just so you know, if you go to the handouts tab here on the upper right-hand side, you can download the brochure for Viasat Real-Time Earth. So if you want to take some information away, physical information away from this webcast, you can, and we'll jump right into it. So I'm going to start right here at the top. We have some audience questions here. First one is simply, what are uplink bands? Aaron, do you
so I guess I could get started.
Sure.
So yeah, the uplink bands that RTE operates within are primarily USB, the unified S-band range, somewhere between 2100 and 2290 megahertz is a go-to for us for uplinking data. And we also have the ability, assuming we could get frequency approvals in some locations, to accomplish what's known as the SIGLES band or Space Ground Link subsystem. It's a unique military band, has a ternary bit associated with it. That's 1755 to 1850 megahertz. It's a little difficult to achieve the authorizations to get that everywhere, but where it is possible, we have the capability to do it.
And just for those of you in the audience, if you're hearing a little bit of static on Eric's line, it's coming from Eric's line. It's not your computer. It goes in and out, but Eric, we can still hear you. It's just you got a little bit of noise online. Aaron, is there anything you want to add to that?
No, I think I saw something else come in about the bands. So as Eli mentioned, the uplink bands S and the SIGLIS, downlink is also S-band, EESS, X-band. So that's like 8025 megahertz to 8400 megahertz, and then the KA band downlink. And again, we've also talked with other customers. This is one of those neat advantages that we have about as being a provider. If somebody needs something else, we can also provide something else. We've talked to other people about having their own antennas that are specialized in different bands at our locations. It's not something we've pursued yet, but it's certainly something that's been on the radar.
All right. The next question here is, do you interface at your POP or at the customer's location? Can you, for example, interface at the military command's technical control?
Yeah, I would start by saying that we do have experience connecting to military customers, and it's an interesting and fascinating part of our business. They do provide unique requirements that we're meeting for them. Those unique requirements range from specific connectivity issues through cyber issues. We really try and help the U.S. government customers get to a commercial offering wherever we can, and help them understand that those capabilities in some instances are actually better than what they asked for originally. So in any case, wherever the customer is, whether they're commercial or government, there will be a need to interface through a VPN and a firewall. Those things can either be hardware boxes or virtualized in the cloud. So it's kind of their choice, customer choice.
Yeah, I just expand on that just a little bit. Just the we provide a secure IPsec VPN tunnel to our customer's destination of choice. So whatever that is, as Eli mentioned, from the firewall to wherever the customer wants it. So that could be at a government facility, it could be at a cloud provider, it could be at a mission operations center or satellite control center. To us, that we become a bent pipe.
The next question here is, what is the automation based upon? Software-defined networking or some other orchestration software?
Yeah, a lot of it's primarily Linux-based. That's how I'd answer that.
Okay. Are KA bands the commercial KA outside of NASA that you're referring to? I guess it's for Aaron.
Yeah, it is against the EESS. So it's 25 gigahertz, or 25 and a half to 27 gigahertz is the receive band that we have, the feeds that we have on site. That could, we could expand that, but that is the current baseline. That's primarily for remote sensing missions, for Earth observation missions, SAR, anything that's looking down on the Earth and providing data about the Earth. Now, it bears mentioning here, Jeff, that is different from our RTE space relay, which is the SATCOM band of Ka band. And again, customer wouldn't really need to worry about that as much, because then it would go over our network and we take care of all of the regulatory process on the Viasat SATCOM Ka band network.
Okay. Then next question, speaking of bands, do you provide an X-band service?
Yes, yeah, absolutely. Again, with primarily the remote sensing band right there, the 8025 to 8400 is the 8400 megahertz for remote sensing missions. Yeah, and I'll go back to what Eli was saying earlier. Primarily, most of our customers are in the LEO orbit, the low Earth orbit, and many times they're either flying maybe demonstration missions or Earth observation missions, remote sensing missions, but we did standardize on a larger size aperture, a larger size antenna dish than a lot of other people out there, which allows us also to go out to the MEO and GEO belt as well.
And I think on X-band, just real quick, we have the capability to do simultaneous left and right hand polarizations. So when customers really need to bring a lot of data down in a single pass, both polarizations can come into the aperture simultaneously, and we can deal with it. So that's I think a discriminator for us in being able to do that.
I'm actually going to piggyback on that because I think that's a really important point. I remember when I first joined Viasat, it was probably sometime around 2015. I went to the satellite conference, actually, and one of the things that we were discussing a lot back then was Viasat 1, Ka-band. A lot of people weren't believers in Ka-band back then. We've since, I think, done a good job of proving them wrong. But one of the main points we made was it's about the bandwidth. And what I mean by that, it's the dollars per bit. So the more bits you can get down, the better economics you can have. RTE is the same thing. Whether it's over X or K band, we are providing our customers the opportunity to get a better dollar per bit efficiency, which when you get into the economics of it, and you start saying, okay, but how much does each individual bit cost me to get down? And how many could I get down? We're having some really interesting customer calls right now and conversations with customers where they say, well, you can do that much. So in 10 minutes, I could do this. And now we're talking fractions of fractions. Right. It really is a unique discriminator for those. It's not everything for everybody. And that's nothing. We've never tried to be everything to everybody. We are seeking a very specific customer set that is interested in the higher performance that we're able to provide in Viasat RTE, and those advantages, those that need a U.S. company or need the cybersecurity assurance that Viasat can provide.
Absolutely, and I remember the doubts over Ka-band and what it could do because it was prevalent around the time I first entered the industry. I spent a lot of time sitting down with companies like Viasat and other satellite operators learning about what Ka-band does. And it's interesting that we're still teaching people about what Ka-band is capable of, but these are all things that you guys knew pretty much from the start. I mean, you, as I remember listening to Mark Dankberg, Viasat CEO, explain the benefits of Ka-band. So, these things were things you guys knew you could do a long time ago, but are still kind of educating people on how powerful it can be. So next question here is, how do operators who lease capacity on multiple satellites use real-time Earth services, or do they?
I can start this, Eli, and I'm sorry, we call Eric Eliason Eli here, so you might hear me call him Eric, you might hear Eli. So I'm a little confused by the question, but let me give it a shot. So operators who lease capacity on multiple satellites, how do they use RTE services, or do they? So one thing I want to be clear about, this isn't a SATCOM service. This is or SATCOM relay services primarily for remote sensing missions. But I would take the opportunity to say there's a lot of satellite operators out there that are flying remote sensing satellites or remote sensing satellite constellations who find themselves in this position of needing multiple ground service providers. And that we do that today. We've partnered with many other of the GSaaS companies out there in those win-win relationships. It's typically one of two paradigms. One is, and one I could talk about openly because it's been in the press quite a lot, was Astroscale, where they partnered with 4 GSaaS providers and they took on the job of integrating a scheduler for all 4 of those providers and managing it themselves. We have other customers that say, I don't have the need, wants, or desires to be integrating multiple providers, but I do need an antenna here. Could you just work through my existing ground service provider to give me access to that geography? And that is something that we are doing as well. So it's whether the onus is on the satellite operator or us as the ground station service providers, we can certainly provide a huge advantage for satellite operators who are looking for increased geography, not just increased geography, but more resilience in your network. Right now, you've got access to different networks. You've got access to different areas, different. When you think about it from a cybersecurity perspective, if one network stumbles, you've got two networks now, so you've doubled your resilience and increase your redundancy in your network. So we are strongly encouraging companies that are saying, well, we're just going to go with this one provider. We say, listen, for a fraction more in integration costs, maybe, or maybe not even, you can have two providers. And even if you don't use the second provider, wouldn't you like to have it in case there's a problem?
Yeah, Aaron, I think you answered the question correctly. We're not a SATCOM service. So if you're, a user on a transponded service, RTE probably is not the solution you're looking for. But if you are a user of data products and those data products are coming down off of satellites, then we would certainly be a good provider for you.
Okay. Our next question is, let me see, let me pull this up. Are the ground stations networked in a way where they can share data without being sent back up, down to another location?
I think the question really is how do we get the data back? And if that's true, then all of our data is sent via fiber, as Aaron mentioned, up to a gig of capacity back to an IP address. So that IP address may be in one of our partnered cloud providers, or it could be to a secure FTP server in some ops center. So today there's no satellite hops between the antenna back to a location as it sits today, and that's primarily because nobody's really asked for it. But we have the fiber backhaul.
Okay. Next question, is Viasat working on the digital IF interface standards-based group segment virtualization, so the DIFI?
Yes, we are. It's not my I know that there is not a consortium, but a group that we are involved with where we are in in-depth discussions with the DIFI. But honestly, it's not my specialty. I'd encourage the asker of that question to reach out offline. I'll get you in touch with the people that are working on that.
Okay. I have a space relay question here now. So what frequencies will be supported with RTE space relay?
Yeah. You want to cover that, Eli?
Yeah. So when a customer is going to participate in the RTE space network, they're going to be considered a user on the Viasat 3 network. And so that'll be in the commercial broadband arena. And it will require, the 27.5 to 30 gigs and the 17.7 to 20.2 gigs bands for the forward link and the return link. And that will require a terminal on top of your spacecraft, but you'll be on the Viasat network as a user. And so Ka band is the short answer.
All right. And I'll ask this other space relay question here. Do you envision your RTA space relay playing a role in a larger resilient communication mesh network? Maybe if that's too in the weeds, can you just talk about the importance of resilience at Viasat? Who wants to?
So yeah, I'll take it. Yeah. So the question, yeah, in the biggest scope is about resilience, and that is something that we're working on, very focused on getting solutions for resiliency. One of the resilient ways is to bring this hybrid network between RTE ground and RTE space. That we think is a massive way to forward the conversation about resilience. There are many ways to talk about resilience, but yeah, I think there's it's a fantastic opportunity to be able to have an always-on communication network, and at the same time be able to download large files through RTE ground through both those networks. Aaron, what do you think?
Yep, I think you got it covered.
All right. Next question has. All right. So this is a spectrum question. So I'll try to get these figures accurate here. So does the RTE ground 7.3 meter SXK antenna use any spectrum at the 2025 2110 megahertz band, which is, I guess, used terrestrially for Part 74 TV broadcast auxiliary services for news gathering? So does it use spectrum in between 2025 2110?
Only if we're authorized to do so. The radios are capable in that part of the band. Yes, that's true. We would need to get approvals. We understand at the same time that those approvals don't always happen because of the electronic news gathering assets. So what we find is in highly populated areas, those approvals are harder to get. But part of what RTE is about is getting out there where we still have good fiber connectivity for the backhaul, and yet still being able to get approvals to do the transmission in that particular band that was just mentioned. So we're very sensitive to that. We're very aware of it. And we do all the coordinations with all the legal entities to ensure that we're good to go.
Yeah, just one more thing I'll add to that is when you are working with Viasat, you're working with greater Viasat. So although RTE is a rather nascent business area in Viasat with about a year of service under our belts, we are relying on a global company that has a full regulatory arm that guides us through this process and helps our customers through the process as well. Typically in most stations, it's the ground segment's responsibility to get licensed for the ground. It's the space segment to get the licenses to transmit down to the ground. But we're able to walk through. We've had customers that haven't had any experience at all in that. Say they're a startup, and it's one of those areas of expertise that we are working. As I mentioned earlier, Viasat 3 is global. It means we're working with almost every country in the world right now as we speak on the regulatory process. We have the connections in their agencies that we know the right forms to fill out. And our customers have found that tremendously helpful.
Okay. Next question. Because you offer the entire network to each customer, do you cover spectrum licensing fees and processing for all sites visible to the customer, whether asked for or not, or do you pass those costs along to the customer?
Yeah, so it varies on a case-by-case basis, and anybody that's delved in too much into the regulatory world of satellites knows that every single country is different. It's amazing. I'll tell you one thing that we've been really happy to see is a lot of changes, a lot of awareness throughout the industry. I'm not going to call out any countries by name right now, but there's been a couple that have been more difficult to work with than others. And in those countries, we have either already seen reform where they said, hey, we're dealing with rules that were set up in the 80s, and it does not apply to today. Or we're seeing people that are about to make changes. So typically with our customers, it's really on a case-by-case basis, but as we've grown our customer base and as we have grown our network, we're able to peanut butter spread the network licensing costs across the network in such a way that it doesn't drive up costs in any way that's noticeable. And that's thanks in large part to our own lobbying efforts in these countries, their own realizations. But we've had here as of late, especially, and by as of late, I mean like within the last month or two, we've been able to really help our customers out there.
Yeah, I'm going to just say one more thing about the spectrum piece of our business. And that is that this is one of the very big reasons why a satellite owner operator actually wants to buy ground station as a service, because this particular topic can be all encompassing. It can be frustrating, and it can be overwhelming. And so when a satellite owner operator is looking to focus on their mission, they can hand that kind of work off to a GSaaS provider like RTE and stay focused on what's important to them, which is getting data products to their customers and letting us go solve the unique intricacies of getting approval in country A versus country Z. And I think it's a real benefit, I think, for the maturity of a satellite owner operator to recognize, what a pain that is, and to hand it off and just buy GSaaS.
Next question is Viasat investigating free space optical solutions for your ground stations?
Free space optical.
I'd say currently no. We've looked at it. We've kind of run some numbers on it. I don't think it's in our near-term plan, but I think there's a lot of promise with free space optical. We'd like to see the space-to-space optical become more successful to start before the space-to-ground piece, becomes more mainstream.
Yeah, I think there's a lot of promise in the space-to-space, and I think if you look at Viasat really closely, you might find that there's a lot of expertise in optical, a lot of the thought leader and experience. So can't comment anything directly on that other than I'd say Viasat, big Viasat is certainly interested.
What software is used to schedule services for remote sensing customers? Can a customer do the scheduling or have to interface with Viasat to get the service?
That's a great question. So our scheduler is API based. It resides in the cloud, so it's highly resilient, highly available, and it can you can access it over a GUI, a web-based GUI, manually. But of course, as we talked about the automation before, and there was a question earlier, where are some of the areas we're using automation? That's another one where we've got a full machine-to-machine based scheduler where we don't have to, customer doesn't have to take it. We don't have to look at it, touch it. You just interact directly over our API. Scheduler passes.
Okay. And just for those of you who are asking, yes, if you registered for this webinar, you'll be able to watch a recording of it 24 hours after we finish the live broadcast today. So if you missed information and you're asking a question about, oh, what did you say 20 minutes ago, you'll be able to see it and watch it again. And also, as I said, you can download the handout. It's got the brochure for real-time Earth. You can download up in the right-hand tab. That may also answer your question if you're asking a stats question. So, all right, this question is will real-time Earth be supporting the 5G build-out in areas of little to no coverage?
I think that the answer initially is no. 5G has some limitations technically when we're trying to integrate into the real-time Earth service as it is today. So that's a little bit of an issue. We recognize the value of 5G. We just don't know that it really fits into what RTE is trying to do today.
Yeah, I think Viasat 3 is certainly looking for integration with 5G and will be integrated with 5G. But real-time Earth is a separate business area for the most part.
The next question is, are you investigating new antenna technology for RTE ground? And I assume the answer here is that Viasat will always be investigating new antenna technology for everything, correct? I mean,
that's a, yeah. No, I think that's one of the hallmarks at Viasat in our culture, which is always keep pushing the edge and look for new technologies that are going to give us a 10x return. That's just embedded in our DNA. So yeah, I think that the right example that I can think of initially is our VHR as a hardware product. You know, we started that with very low data rates, but a very resilient and reliable system. And that evolution, if you're familiar with the VHR, has got us to a point from the VHR 400 to the 6400, which is a completely amazing system. So yeah, I think just from that one example, it's true. I think phased array systems, electronically steered array systems, also fascinating in the world of what we're trying to do. So yeah, we're excited.
Mm-hmm.
All right. We got time for a couple more here. Does Viasat plan on using the cloud to do some of the back-end digitized processing?
Yes, we are in close communication with some cloud providers. It's an interesting puzzle to figure out, to be honest with you. So if you're talking about narrowband communications, that becomes quite easy using DigRF, sending that over to the cloud and having processing done there. But you have to think for large amounts of payload data, if you're using DigRF, you're talking about 10x the amount of bandwidth needed. So if I've got somebody downlinking at a gigabit per second, I want to send DigRF directly to the cloud for processing and not demodulating it first, you're talking about I need a 10 gigabit per second circuit, which, you know, maybe that's available, maybe it's not, maybe it's more costly, maybe it's not, maybe it's more effective to have a cloud at the edge solution where we put the cloud right at our ground station. All of these are things that we are studying quite intently right now and working with our partners in the cloud community on.
Yeah, I think the cloud has done so much for space at whole, right? I mean, the cloud has been an enabler. That ecosystem that you know, Microsoft and AWS and Oracle are bringing to the missions isn't just limited by the digital IF piece. It is so exciting when you really start thinking about the concept of operations that a satellite operator can bring together and the data fusion that can happen inside the cloud. It's completely mind-blowing, and we live in an exciting time in the space industry, and a lot of that is due to the cloud.
And let me add one more thing there really quick, because it also gets, somebody had asked about polar region or polar coverage earlier, and the answer is yes, we are covering the polar regions with Sweden and moving. We're looking at a site in Inuvik, Canada, right now as well to accompany that to cover the polar regions. But again, right there in our Ojib in Sweden site, we have a private cloud at the site that we can take advantage of. And then also, just to throw that in there again, it's 7.3 meter antenna like we've discussed, but I saw something earlier about, is that able to track NGSO orbits or you know, LEO? And yes, absolutely. In fact, we've done the analysis on the speed of our 7.3 meter, which is an XY axis for those that are interested in the pedestals, which means it has no keyhole effect. You've got full coverage, and we can track everything, including the very low Earth orbit satellites that are on the horizon that are really zooming across the sky.
And this will be our last audience question. I was wondering if somebody was going to ask this one because you talked about space relay, but any plans for lunar, cislunar comms using RTE space relay by Viasat?
Ooh, That's a good one. Let me plug our amazing folks in Antenna Systems really quick. And if you ever come by Atlanta, Georgia, you might see some huge antennas by the side of I-85, 24-meter antennas, fully capable of lunar and cislunar comms. We fully anticipate being a very big provider of antenna systems for the upcoming lunar economy, let's call it. Right now in RTE, we're not set up to provide lunar comms. Who knows what the future holds, but that's not where we're set up right now. And as far as enabling that over the space relay service, that's an interesting concept. I'd like to talk about that more. And since that's the last question, let me offer an opportunity to talk about that more. Both Eli and myself and team from our space relay, our RTE space relay team, will be at GeoEnt next week. So happy to, we have a booth out there and some meeting rooms. Come track us down and let's continue those conversations.
Excellent. Excellent. Well, as I said, that's all the time we have for questions and for the webcast. Eric, Aaron, thank you so much for, I mean, you've answered, we have a ton of questions here. If we didn't get to your question, by the way, as I said, they'll reach out to you offline, but thank you guys for spending 40 solid minutes here answering all of these questions that came in. It was an excellent presentation.
That was a lot of fun. I enjoyed it. Thank you for the opportunity, Jeff.
Absolutely. And thank all of you in the audience for being with us here for this webcast. And thank you to our webcast sponsor here, Viasat. Once again, my name is Jeffrey Hill. You've been watching a Via Satellite technology webcast series on ground systems as a service presented by Viasat. If you, as I said, if you asked a question or you have a question, please send it our way through the portal before you leave here so that Eric and Aaron and the team at Viasat can reach out to you. But that's all for today. I have another one that I'm hosting on Thursday with Comtech. So if you're watching all of these webcast series, I'll see you in a couple of days. Otherwise, stay tuned for more from Viasatellite. I just called it Viasatellite, and I've been working for this magazine for 15 years. Viasatellite. Viasat, Viasatellite is the most common confusion I get, at least from our readers. But thank you all so much for joining us. Have a great afternoon. We'll see you all soon.
Thanks, guys. Well done.